Let me just think about this. I don't want to do the one that's in the book. I want to do something slightly different. So let's take 30 seconds here, maybe a minute. How are y'all feeling about this? I mean, for many of you, this is the first exposure. Some of you have seen this. How do y'all feel about it? I mean, any opinions or?
Looks an awful lot like the negative sign, arc sign.
Oh, I'm not saying this. I'm just in general. Like, how do you feel? How do you feel about, like, so far this? Everyone's clear on it's just going to be practice and practice? Okay. So if you're going to watch my homework solution videos on this, my recommendation is to not watch me get you. You go get you, and then watch my videos and see if your you and my you are the same. All right? Yes?
So is there still only one right, one correct you?
There are times where you can have different substitutions that'll get you there, but they're all going to be somewhat related or similar. Most of the time on these U sub problems, there is really only one U sub that'll do it. But I could come up with a problem where you could do it two different ways. Like one example is like, and this is kind of I'm kind of cheating here, but like that right there, dx. That could be done either way. You could let u be sine x, or you could let u be cosine x. Either one would work. All right, so there you go. There it is. And who's up to bat? Heidi. Heidi's not here. Okay. And Corey. Corey's not here. This is really. Oh, you're here. You've already answered though, right? You've already kind of. You want to go for it? You're working. Okay, Corey. I'm going to put you back burner for now. I'm going to get someone else on this. We're going to put someone. What did you try? Oh, okay, so you did square root of each of those individually?
Oh, no, I just separated the problem so I could see it better. So, like, it's 1 over square root of x squared plus 1.
I thought you said x squared plus 1. Okay, 1 over the square root of x to the 4th plus 1 times x to the 5th dx. Okay, I'm totally misheard you. Okay, so that's where you start. I like that because that kind of peels everything apart.
So now I'm trying to figure out what if I take u, what derivative, or sorry, what if my u is like what derivative get me x to the 5th? Like
yeah.
So I did that u equals x to the 4th plus 1.
Okay. Why not use u as x to the 5th? Just curious. Why not use u to the is x to the 5th? Because what is the derivative of x to the 5th? 5x to the 4th? Do you have x to the 4th in there? You do, but what's wrong with that approach? The x4th is like under a root in the denominator, totally trapped, right? And the whole idea behind it is that whatever you pick for u, its derivative, you don't want it to be trapped anywhere. You want it to be able to be slid off to the side like this. Okay, so, all right, so you didn't do that. You wanted to go with u as x to the 4th plus 1?
I think what I did is I worked backwards and I was trying to find the antiderivative of x to the 4th that could get me to the 5th power.
Okay.
And match that x to the 5th power.
Okay. I kind of like the idea of just sticking with what you've got right here. Okay. Yes, Chris?
So
yes.
You said it can be trapped, but then we had the one where it was ln x was trapped inside the square root. So
The derivative wasn't, though. What was the derivative of natural log of x? It was the 1 over x dx. That part wasn't trapped. The something that you picked, the u, that can be trapped and all jacked up. It's the derivative of that that has to be able to be slid to the side. And the reason it has to be slid to the side is because this eventually becomes du. You can't have du in a root or something. The du always has to be off to the side. Does that make sense? Okay. So I feel the heat in here, you know, that you're talking about. But I'm thinking about, you know, like Isaac Newton out in his shed, like developing calculus on his own without air conditioning or anything like that, you know. Yeah, but he had the added dilemma of no one had ever done this before. So, you know, I think we'll just try and tough it out
he
here.
had a little bit of grit.
Yeah.
You also have to take into consideration your own individual metabolism rate. Like, look at me, I'm in a fully wool onesie. I'm not sweating, but if you're sweating and the entire you are, then maybe your metabolism.
Bears' metabolisms are much different than humans. Very different.
What did you say?
A bear's metabolism? Yes. Yeah, so, I mean, you're used to it. You're used to, you know, hibernation and carrying all that weight with you and all that. Okay, back to this. X to the 4th plus 1. So take the derivative. Okay, so du is 4x cubed dx, and not because I don't want to hear more from you, I just want to try and get through all the names here. So I really have a hard time with this name. Not pronouncing it, but I can't. Is it Gabriel or is it Gabrielle? How do I know the difference?
Gabrielle has 2 L's and an E at the end.
Really?
Usually.
Gabriel?
Yeah.
Okay. No, I don't know. Like, I just don't know.
That's fine.
That's why I'm not an English major. Because, you know that whole I before E rule?
Yeah.
How does that go?
I before E, except after C.
Except other times that it actually is okay?
Yeah.
So that never worked with my brain. You can't have rules that have exceptions. Mathematics, we don't have that, okay? Rules are rules. So, Gabriel,
Yeah.
all right, I'm going, I don't know, what do you want to do?
I don't know.
This is where we are so far, right? This is where we are so far?
Well, can we?
I mean, the big problem is that x to the 5th, isn't it?
Yeah.
I mean, that is a huge, huge dilemma for us.
What about X to the 3rd squared?
You could rewrite it as x to the 3rd squared, couldn't you? I mean, that's just like craziness now, right? I mean, that is x to the 3rd times x squared times dx. Yeah? Who suggested that? It's nonsense. Yeah, okay, so I mean, let's just see. We're just going to follow you. Let's see what happens. So let's see. Do we have, see we have x to the 3rd dx? And here, don't we have x to the 3rd dx? So could I rewrite this as 1/4 du is x to the 3rd dx? Could I do that?
Yes.
Yeah. And so this right here can be replaced with 1/4 du. So what I'm saying is this and this we have a home for, don't we? We have that's matched up. We can get that in terms of u. What about the x to the 4th plus 1? This piece right here, we've got a home for that, right? This piece right here, just that is going to become u, yes? What do we not have a home for yet? X squared, right? That's the one kind of missing element here, is this piece right here, x squared.
Would that cancel with the square root?
How do you mean? It's not under the root though.
No, never.
Could you multiply both sides by, not both sides, X, you can't do that. You could factor out an X squared technically, because the square root represents a squared. So if you have,
I saw a hand over here, so
if
hold
you
on.
can convert X to the 4th plus 1 to X to the 4th plus 1 to the 1/2, you could factor out an X.
Can you factor an x out of that? I don't think you can get an x out of that.
Never been one certain amount of problem.
Okay, good, good. What do you got?
For X squared,
How?
use the U equals X to the 4th plus.
Go back up to this and solve for x squared. Does that seem reasonable to everyone that we can maybe do that? How would you do that? So subtract 1 from both sides, and then you have what? X to the 4th, right? And now square root both sides. So just subtract 1 on both sides, and then take the square root. So when we do square root, we get square root u minus 1 equals x squared now, right? It's plus or minus, but x squared has to be positive, right? So we good? I'm totally okay with that. Shall we proceed? Do we have x squared in terms of u? Yes, we do. All right. The whole purpose of this problem is just to force you to try something that you wouldn't have tried. I'm not sure we're going to get to it, all right? But everything we're doing right now is legal, right? We made a substitution. There's our derivative. We kind of played with it. Solve for x squared. Let's rewrite, and let's see. Stephen? Stephen, you're probably okay. You came up with the arctan part. So I'm happy to move on unless you want to. Okay, Chris Ochoa?
You can rewrite it as
Okay, so we're going to rewrite it, right? So tell me how to rewrite this integral right here.
1 over u.
1 over, not u,
Oh, in,
square root of u, right? Square root of u, okay, and then times,
times 1/4 du.
okay, 1/4 du. Can I bring the 1/4 out here? Du way out. That takes care of the blue part.
Yeah.
Green part?
The square root of u minus 1.
Square root of u minus 1. Okay. Everyone see where everything came from? 1 over square root of u. The x cubed dx became our du. Or sorry, our 1/4 du. And then this x squared is where we solved for the x squared up there. Anything you can do with that?
Could you separate, so could it be like in the numerator, u to the 1/2 minus 1 to the 1/2 over u to the 1/2, and then get rid of the 1/2?
You can rewrite this as u minus 1 to the half, but you cannot then rewrite that as u to the half minus 1 to the half. You can't apply it to each one because there's subtraction. We could do this though.
What about the 1 over square root if you turn it to u to the negative 1/2 power?
Okay, u to the negative 1/2 power. And then what you want, yeah, so you're bringing it up.
And then since that u to the minus 1 has the half power, maybe you can get rid of this too because you have a positive and a negative.
Yeah, you could do that. How about this though? I mean, how about just doing this? Like, you have a root on the top and a root on the bottom, right? So if you have a root on top and a root on the bottom, you can just put them underneath the same root. Do y'all agree? Okay, now I'm not sure we've gotten ourselves any closer to the result here. I'm just doing what I'm legally allowed to do up here. So here we can actually split this up, right? U over this, 1 over this. So that would become square root of u over u is 1 minus 1 over u du. And I think at this point right here, we're going to be game over, okay? I think at this point we're stuck. Does everyone follow everything we've done up to this point? Okay? Yes? Just because there's 2 terms over 1 term, I can do u over u, which is 1, minus 1 over u, which is 1 over u. So I just split it into 2. Okay, so look, if that square root wasn't there, could you do that? The antiderivative of 1 would be u. The antiderivative of 1 over u would be natural log of absolute value of u, right? If the root wasn't there. Okay, so can you just square it out of nowhere? No, we learned that way in the beginning. You can't just square it. So right now, I mean, we've cleaned it up pretty good. I mean, it looks not that bad compared to what it started out as, but this doesn't seem like something we can do. Would you all agree? Yeah? So what does that mean? That means maybe our substitution here doesn't work, which means that I wouldn't ball it up and throw it away. Okay, I wouldn't do that because there was a lot of really good work in here, right? There's a lot of things that we tried, like this whole thing right here, solving for x squared. That's something we need to be aware of that we can do. It just didn't work for us in this problem. But it's a good method. This right here is a good method. Splitting that x to the 5th up into x cubed times x squared, that's a good thing, right? Okay. So what are we going to do? Probably just start it over, right? Start it over. Now, I'm going to tell you right now that you're still going to get stuck, okay? The point of me putting this problem on the board is to say to you, look, stay tuned, all right? Like, we can't do this yet. We are still limited in what we can do. Yeah, we can use the substitution to try and make an integral look better, but we may still get to a point where we're stuck. And so we need more than just substitution, all right? We need more than just substitution. We need some way of dealing with something like this, maybe. All right, so we are just taking our first steps into the integration abyss. Yes?
Can we use integration by parts?
I don't see that method working here. No. Yes?
So you're saying that up until you get to that point, you're okay, but then once we learn this new method, we can solve something like that?
Well, methods, okay, so we need to, I guess I need to clarify. What we have in Cal 1 are like the rules, right? Product rule, quotient rule, chain rule. When we're trying to find antiderivatives, we have techniques, okay, or methods. They're not guaranteed to work. They're just, they might work. It depends on the problem, all right? So what I'm telling you is up to this point right here, there may be a technique of integration that we learn that will be able to handle this, all right? Now, I can almost with certainty tell you that no technique I'm going to teach you is going to handle this. And there's an easy way to check. I'm going to go to Wolfram Alpha, which I'm sure you've heard of. There's other sites out there that you could go to. Come on, man. What's going on? Hurry up. Wow. Okay, so if I type in integrate, caps lock on? Yeah. Integrate, what was it? X to the 5th?
Square root of x to the 4th plus 1.
X to the 5th over square root of x to
x to the 4th plus
1.
1.
Okay, so I just went to this website, typed in integrate that. Yeah, and I'll just hit enter, and then we'll see. I'll be able to tell you from the answer right away.
Another parentheses.
Did I forget? Oops, yeah, thank you. Oh, it is doable. It is doable. Okay, it is doable. Now, it involves the inverse hyperbolic sine function. Okay, so if we look on our formula sheets, what's the derivative? What's the derivative of the inverse hyperbolic of x?
1 over square root of 1 plus.
For the inverse hyperbolic? I don't think so. Let me see.
1 over 1.
Oh, it is. Okay, yeah. Yeah, so, but it involves that, but it has x squared in here. Yes?
So this, for that, where they use integration by parts then?
It looks like it's integration by parts. It looks like it is, yeah.
Is this free to use?
Pardon?
Is this free to use?
Yeah, anyone in the world can use it. Yeah. What are the other places? There's other places. Now. You have to pay if you want to see a step-by-step solution as to how they got it. But there's other websites. There's another one that gives you the steps free. What is it called? Symbolab. Symbolab. All right, so what time is it? Okay, I don't really have time to start a problem. Do y'all want to just try something else on that one? Maybe we can get to it. I didn't think we would be able to. Just by the look of it. Just didn't feel like it was going to work out, but apparently it does. So just to kind of stress again, if we can't do it with a method, there is still a way to do it. But it requires that we learn what are called power series, which is chapter 8 out of this book. And this was the big distinguishing factor between Isaac Newton and Leibniz, the two fathers of calculus. Newton had power series, and Leibniz didn't. And so there are integrals that you could give both these guys, and Leibniz would just be like this, just kind of like, sorry, I have no method for this. And Newton had a way. And pretty much that's the way computers work. If you need to do an integral on a computer, or an antiderivative on a computer, it's going to use power series to do it. So even if we can't do the integral, like here's an example of an integral, no method you ever learn, nothing you're ever taught, you're never going to be able to find the antiderivative of e to the negative x squared. Just never going to happen. Okay? Just not. No matter what I teach you. But Newton has a way. All right? Newton has a way. You have to write that as a power series. I promise you we'll do that problem at the end of the semester. All right? We'll do that. We'll find the antiderivative. But it'll be a power series as opposed to like a nice definite answer. And you'll understand what I mean once we get there. We're kind of like getting the carriage in front of the horse right now. Okay, I can't really explain it until we get there. But there's major differences between the two different calculus, I guess, that Newton and Leibniz came up with. So let me go back to the original problem. Right here. Because we're almost out of time, right? I'm going to call the attendance here. I'm just going to finish these off. These people who didn't get called today will be first up next time. Jonathan here, not. Rasul's here. David. And Edward. Where is he? Where's Edward? Mr. Cope. Oh, I didn't see him. Okay. And Martin and Michelle. No Michelle. All right. So here's kind of what I was thinking maybe, is rewrite this like this and rewrite this as 1 plus x squared dx. You see that? And then let u be equal to x squared. And then du would be equal to what? 2x dx. Right? Go with me? Now I can rewrite the x to the fifth how? Because I have an x dx, right? So I could rewrite this as like x to the fourth times x. You'll see that? So I have the x dx. Here's x dx. I have a 2. I don't want that. So I multiply both sides by a half. Okay, and now they match up perfectly. So I can replace this with 1/2 du, right? The bottom becomes square root of 1 plus what? X squared. So this is going to be my u, right? That's my u. The only thing is I need to figure out what x to the fourth is. So what's x to the fourth? Just come and square both sides of this. This is u squared equals x to the fourth, right? Okay, let's rewrite the whole integral. All right, x to the fourth is u squared over bottom square root of 1 plus u squared, right? That's u squared. And then 1/2 du is the rest.
Sorry, how did you get rid of the x in the numerator?
What x?
Sorry.
This x
How
dx?
did it become a u squared instead of u to the fourth times x?
Because I'm saying u is x squared. That's my substitution. So x to the fourth, I square both sides of this. X to the fourth is u squared. If I square both sides of this. Right? So that becomes u squared. That becomes 1/2 du, and that becomes square root of 1 plus u squared. Now that may not look as nice It's the one we just had a second ago. But this will go with the next technique that we're going to learn next class, which is integration by parts. And this might be a good example to show when we do integration by parts. Maybe not the first one, but it'll be one that we can do. All right? So I see it from here. This will work. All right? So that substitution, right, may not be that natural that you do that one, but it works better than if you let u be x to the fourth. Okay, so your job, oh, we have a test a week from today, right?
Yes.
Yes, we have our first exam a week from today. And the reason it's a week from today is because I'm going to be out of town that day. So next Monday I will not be here. I will have a proctor coming in to deliver the test. And so that test will cover everything up through what we complete next class, which should be the beginning parts of integration by parts. I would not expect for me to hand out a review. Okay, I do not expect that. What I will do is on Wednesday, I will come in and at the end of class, I will talk to you about specifically what you should kind of focus on. But I'm basically going to tell you the same thing I'm telling you now, which is do your homework, okay? Do your homework and study your homework. And the problems from the test will be within the scope of what I ask you to do on homework and whatever we've done in class. All right? So I don't know yet as far as number of questions. I told you that I don't know if I said this. I make a test. I take the test. I see how long it takes me. Multiply by 6. So it always depends. I mean, later on the problems become longer. So you know.
Yeah. So that previous calc.
Yeah.